So in our processes, I think there's design planning. Very early in the process, we're doing the product requirements document. Um, and there's a little bit of industrial design kind of mixed up in that, meaning industrial, you have to do a little bit of industrial design to figure out what the product requirements are. For instance, do you want a product covered with buttons that you press, or do you want a screen with virtual buttons? And those are very difficult, very different design processes. One involving software to do it all virtually, and otherwise it's actual hardware when you're mounting buttons and wiring them up, right? So there's certainly a little bit of industrial design going on while you're developing the product requirements document. So there's an iteration there. And then, of course, then you look at the product requirements and you figure out, wow, what they've asked for is going to be really expensive, and then there might be more iterations because they don't like the cost implications of what they put in the requirements document. So when you start doing some of the design work, the first thing that you want to do is kind of get the overall budget in place to figure out, because there may be a cost design target in the requirements document. There should be. So one of the first things that the design team is going to do is divide the product up into different areas, like the enclosure versus the electronics, depending upon what it does, the sensors, and you assign budgets to that based upon what you really think it's going to cost. And then if you hit the target that's in the PRD, you think, well, okay, product requirements document seems reasonable. Our design approach seems to be on a path to hit that. You want to make sure that you're not being overly optimistic nor overly conservative, so that you've got a good shot to hit the target and still be able to do everything that's needed. That's some systems engineering and estimating that's going along with the industrial design and writing the product requirements document. If a customer says, I know exactly what I want, here's the product requirements document, not interested in what it costs, just do it. Well, I've never run into someone like that, but that way you don't have to iterate, you just have the product requirements document and you go. But usually the design team's involved in writing the requirements document, first so that they understand it, but second so that they can identify things that might be very expensive and have work with the customer to figure out if it's worth it. And then once all the teams are on board with the product requirements document, then the industrial design team can finalize the industrial design, and the engineering team, meanwhile, is probably building an alpha prototype to prove that the guts of the product, meaning the part that is not in the industrial design, which tends to be the way the product interfaces with the user, is largely industrial design, where the product interfaces with whatever it's measuring or working on, or some database where it's interfacing to hardware. That's not industrial design. Now you're at design engineering, so you kind of have to meld those two together. It's a different alpha prototype. So realistically, you could have two alpha prototypes doing completely different things. One would be a mock-up of the product and how it looks and how it's going to sit on a table or on the floor or whatever, and where is its computer screen, and where is its if there's a keyboard, where is that going to be, and where are the connections going to be, and how are the users going to interact with this thing. It could also include industrial design for the user interface. If, let's say, it's a software user interface, when it turns on. This is what the screen will look like when it comes up. And these input fields will present themselves for you to, I don't know, authenticate or enter data into, or there'll be some button that you can press that will turn something on. And then as you navigate through the different things that the product can do, you know, this is in software, so you've got to navigate through different screens. It's an unusual product that has all the controls on one screen because they tend to get very busy like that. But it's possible.
You know, alpha prototypes, like you said, one of them will represent how the unit looks, but spin it a different way. That's an experiment in and itself, because you want to know with the industrial design of that product, how do people interact with it? How do you want them to interact with it? What do you want them to see and feel and gather with this product? So there could be one alpha prototype that is for nothing more than, hey, what do you think of the look of this? And people will say, well, the screen's too vertical, I want it to be on an angle, or the screen's too low, or this button should be over there, or I want handles, or whatever. So if you spin it like it's an experiment of the user interaction, that tells you a lot. And that's an ID alpha prototype.
Yeah, and on the other hand, the product typically, like we tend to build instrumentation, it has to do something physical. It's got to measure a pressure, or it's got to apply a pressure, or both. Or in some cases, it has to blend a smoothie. So, you know, you not only have to consider how the user is going to interact with the machine, but also how the hardware that it connects to or touches interacts with the machine as well. And that I think that tends to be easier because you can define the actions of a piece of hardware, I think, tighter than you can define the actions of a user. So, you know, you have all kinds of users walk up to a piece of equipment and need to use it. That's why we ask questions like, will these users have to be trained before they can use it? Because if you're allowing untrained people to come up to it, well, it better be pretty simple. I mean, you look at the soft drink machines that are in the restaurants now with I don't know how many hundred different flavors of soda they can come up with, where it used to be all you had to do is take a cup and go up and stick it under a nozzle, and you would get one of three or four or half a dozen choices. Now you set the cup down and you look at this screen, which is usually pretty big, and you find some icon that it leads you down a path to get the soda that you want with the extra flavors that you want. I mean, and then you have to do something to cause it to dispense that drink. And now you get all this flexibility and you can get whatever you want. That's a completely different user experience than just walking in and shoving it under the Coca-Cola nozzle and then walking away, which is very simple but very limited. So, you know, with that flexibility comes a lot of complexity, and you got to deal with that. When you're actually on the other side of the machine, though, you've got, I don't know how many flavor packets, each with a little valve that needs to be opened, right? And maybe you've got to pressure them up. Well, those are pretty simple when it comes down to it. You know how you're going to operate them, and it's easy to talk to that kind of equipment. It's a lot harder to talk to the user, especially when the user can be 6 years old or 60 years old, and want something simple and want it right now versus, you know, wanting to concoct some really bizarre thing. I mean, there's all kinds of all kinds of different users with different skill levels. The hardware is
Yeah.
actually easier to deal with. And the prototypes are there to prove that it is possible to deliver the requirements that are in the PRD. So if you say that you've got to, if the PRD says that you must be able to measure a pressure to 1 millibar, that's actually a pretty easy target to hit, but let's say it wasn't, maybe a microbar, right? And there's not some doubt, but you need to prove that you've got the right components in mind, that when you string them all together, you can make that measurement accurately. You would put together an alpha prototype and you would take the measures and you would demonstrate that, yeah, I can make that measurement. Now it's just a matter of packaging it up, maybe cost reducing it or something like that. But you know that you can do it because every product that comes out, there's always something in there that's a stretch. Because if all was very well understood and you would just do it, it's probably been done in their reference designs. But where you're doing something new, there are going to be things about the design that have additional risk, like, gee, can we measure that to that level of accuracy and still stay within your cost budget? For instance, if the cost budget was $500 and the only pressure sensors that you can find that will measure to the accuracy in the PRD cost $1,000, you're going to miss the target. So you've got to come up with a way to make that measurement without spending more than $500. So, and that might cause the project to stop and people to weigh in on it and think, okay, can we get more money for this thing? No. Can we back off on the accuracy of the measurement? Well, if we do, how much, how good can it be for $500? And then, there would be some work done to determine that, yeah, for $500, I can make it this measurement to this accuracy. That's good enough. Or nope, that's not good enough. We need to do something. And then maybe they're asking for something that simply can't be done for the cost. Those are the kind of, and none of this is nailed down. You can't say, oh yeah, it's going to be $493.12 because you know that you don't know that. All you can do is identify the parts and put budgetary numbers down and say, yeah, I think that we can do this. And then you'd go and you'd build an alpha prototype. And even though the alpha prototype costs more because it's all hand built by engineers, in production, this should be under $500. And from that, it gives everyone the confidence to proceed with the project and with the real design engineering, where you're not using, prototype parts and prototype boards and hand wiring. You're actually committing it down to circuit boards and mechanical parts.
There was a product that we designed, oh boy, 7 years ago now. Holy moly. When we were designing it, we had the PRD and there were a bunch of requirements that were initially put on there. And then we went kind of into the initial design and alpha prototyping. And man, forgive me, I'm counting out loud, but we had an alpha prototype for, the look and the feel of the system. We had an alpha prototype to test thermal parameters. How hot does it get in the box? How much heat does we need to dissipate? All that. We had an alpha prototype for a manifold that we had to custom design, and we wanted to test the feasibility of the manifold. We had an alpha prototype for a pressure regulator or pressure regulating system. I'm trying to think if there were anything else.
And the pressure measurement system.
And the pressure measurement system.
Yep.
So all of these different alpha prototypes tested, experimented with a singular aspect of what would be the final device. And based off of what we found in those experiments, we either decided, like John said, that the requirements can stand. Yes, we can hit this target for pressure regulation. We found a pressure regulator that will do it. We have experiments to prove it. let's rock. But then, over in the thermal dissipation alpha prototype, well, we don't want the temperature to get above 38 degrees C inside the box, but we did all of our testing and it hit 40. Well, do we either need to mitigate it or can we live with 40 degrees? It tells you a lot. So each one of those alpha prototypes told us something, and then we would iterate back on the PRD, either decide the PRD needed to be updated or the PRD needed to stand and the design needed to change. So it's a bit of an iterative loop, but what the PRD does by doing it up front, it puts a stake in the ground. And it says, these are the targets to start with. We can decide to change them later, but here's something to shoot for. And then our investigations through alpha prototyping and design can iterate back on an updated PRD to then ultimately lead into the product design that compiles all of this information.
And this is an ongoing process. So there's a lot of massaging the PRD early in the project, but even towards the end of the project, we're going back to the requirements document and there's some massaging. For instance, when you finally get to, let's say, regulatory approval and you're going for an IP rating, maybe there's a target IP rating, which is difficult to meet. And maybe it just doesn't quite get what they, the target rating, but there's a fallback, well, this is acceptable. Or it's, okay, we can meet the rating that's in the PRD, but we're going to have to make a modification to this part of the system because testing determined that it wouldn't exactly meet it. And because you can only go, some of these things where the performance and you're really right on the line and you're trying to hit all of these different targets, you have to be able to either hit it or go back and have the requirements document changed, because that's changing the requirements document is communicating back up the chain to everybody exactly what the device can do, because you don't need the marketing team going off saying you can use this thing underwater when you know darn good and well it's plugged into the AC mains and you can't use it underwater because it was never designed for that. You need to be able to accurately state what it can do. Because as soon as they start going out to customers and promising things like it can work underwater, then it's a lot harder to back off on the requirements document.
But that's true. I mean, that requirements document, that gets everyone on the same page. So when you're doing your alpha prototype design and you're kind of iterating back to the PRD, it allows the customer, the end customer, whoever's product this is, to make strategic decisions. Well, I can let this parameter slide a little bit. Maybe we need IP56, but we can only get away with IP54. Well, okay, I'll live with that, but then the price has to go up or down or something like that. But it puts everything in one spot so you can see what concessions you're making and get everyone on the same page with them as well.
Yes, I mean the stages of product design, they're real, but you're always jumping back and forth between them. It's more like you take all the stages and you put them in a washing machine and you run it for a couple of cycles, and then when you're done, it all comes out nice and clean and working. But it's a lot of iteration and a lot of scrubbing and cleaning between inception and final product.
Yeah, and I know with these phases, it kind of does block it out. It makes it look like it's a first step, second step, third step kind of thing. And in a very high level, that's kind of true, but there's a lot of iteration in there throughout that whole process.